All right. Good evening. So today will be the second day for the week two. Sorry, I've not been that consistent with this video. But for today, we'll be looking at functions. Yeah. So functions. Function is one of the major things we will always come across in Python programming, right? So it's something we have to really understand. So what are the learning objectives for this particular topic? The first thing is that we will understand how to define and call functions in Python. So that's just the basic objective for, or let's say the primary objective of this topic this evening. And then how to also differentiate between parameters, arguments, and return values, right? And we also have a grasp of the concepts of global and local variables and how it affects our variable accessibility. And at the end, we'll see how to reuse or how to write reusable functions in for mathematical computations, right? So if you look at some basic functions like the sum, you realize that those guys are reusable. So we'll learn how to write those reusable functions as well. So defining and calling a function is a reusable block of code. So when we talk of a function, we are referring to a block of code that you can reuse, right? And then being a block of code that you can reuse, that function should be able to do what? To perform a specific task, if not more than one task, but at least should be able to perform what? A specific task. And then functions helps them in modularizing our code and avoiding repetitions. So modularizing like giving your code that beauty and trying to see how you don't always repeat a particular variable owing to the fact that that variable has already been captured in your function. So whenever you make use of that function, it will account for the tags and the variables that are inherent in it, right? So let's take a look at the example. For this first line of code, I have that DEF. So by way of saying DEF, that means you're defining, right? So DEF is a short keyword for define. So you see it as define function name, right? So when you write your DEF defined, you give a space. So what comes next is the function name, right? So this function name should always depict what you want that function to be. So assuming I want to have a function that when I enter two parameters, yeah, two parameters, it will give me the sum of those two parameters or the difference between those two parameters. I will want to name my function. I want to give my function name to be add numbers, right? Or add underscore norms. So that by so doing, it will help me, it will already give an insight to the fact that whenever I see this function, add um add norm, it means that it will be adding the two parameters or the two values that are inside the function, right? So this blue characters represents the function name, right? And then Okay. The next is this guy. This one inside the bracket is where you initiate your parameters. So you define first the function name, you give it a name, and then the parameters you want to work with. Let's say, for instance, okay, we are trying to determine the how do they call it now? The absolute permeability of a particular reservoir, right? So, no, let's work with relative permeability first. So, if you're trying to get the relative permeability, you need the permeability and the absolute permeability, right? So, you can always note that, okay, for you to get the relative permeability, the parameters you need are what? Your absolute permeability and the normal permeability. Then you will now have, okay, I've not talked about this column. The column will tell you that, look, what you're going to do after this column is what you're going to have a block of code. And that is why there is this space here. This space is called the indentation. The indentation shows you that, okay, what you're doing, you're dealing with a particular block of code, right? So that is what it is. So you can only have this indentation when you're handling a new block of code. And also the same thing happens here. But once you're back to your start point, you realize that that block of code is done with, right? So let's try to explain this other one. So here is where you're going to write your code. Let's fall back to our addition. So let me say I have a function name, add numbers, and here I'll have num1, then num2, right? So thereafter, I can come here under my block code. I say addition is equal to add num this, right? And then here will be your return addition, isn't it? Then this return is just like your print function. But what return does is that it helps stores that value or that particular output you have, so that when next you're reusing this function known as function underscore name, it will give you the exact output that you got here. But it's usually optional, right? So you might decide to want to use your regular print function, but following the Zine of Python, return is preferable when you're dealing with what uh how do they call it now? With functions. So we'll run this. So this is another thing now. When you run this kind of code that has a return, there will be no display. Are we getting? There will be no display here. So reason is that you have not initiated the parameters. Okay, so let's use line 4 to explain this better. So I have a block here that say greet. So it is defined as def, right? And I have greet. Okay, I'm coming. Let me see how to do something now. Okay, let's remove this guy from here. All right, we can have another one here. Okay, so I have define greets. Greet is my function name. So wherever you say this, you know that you're greeting. It's a greeting, right? And then this is name, the person name you want to greet. So the block of code inside of this is what is print format hello, right? Then the value you want to. So this parameter now is what you've initiated here already, right? And then remember when I told you about your code not running. This is it now. The number, how do they call it? The line 2 did not run as well. So, but we can have it run only, it ran actually, but it will not display anything, right? But the only time it will display is when you call the function. That's why I have a comment here known as what? Calling calling the function. Calling the function. So if I'm calling the function now, this is the function. Remember the function name was what? Greet. Then I open a bracket. Whenever I call this greet guy, I should always have something inside of this my bracket. And what is expected of greet is what? A name. So I have Eben inside of this. So if I run this, it will be telling me what? Hello, Eben. So well, that's I think that was simple enough. Simple enough, right? And then so here is it now. I need to still make use of the same function. Let's say we have several users and combating our system, and then we want to send a greeting to them. So we will have this guy to always come and then just give the user, okay, the user the name, the function name rather, and the parameter. So let's try to run this again and see. Oh, sorry, this is in raw and we let's put it on our code. All right, so when we run this, it will say what? Hello, Ben, right? So that is the simplest thing about functions. User-defined functions. So this are what we should know. So let's break down other things that are relevant as well. So we have parameters, we have arguments, and what we have the return value. I know I've talked about this, but I want to also try to uh, try to see how we can um, digest this more and more. So let's explain it one after another. I'm saying here that variables defined in the function signature to accept inputs are known as what? Parameters. So if you look at this guy, the variable that is defined in, in the function signature, right, to accept input. So this is the only variable that allows me to be changing this guy. So this is the inputs we are talking about. So you can always change these inputs. So even if I want to have another guy come in, so I can say hello Tom, right? Let's say hello Tom. Yes. Okay. Let's have TY. Taiwo, Abi? Is it TY? Yeah. So this is just it. So no matter the name you put inside of this guy, it will always do what? Bring out what I'm saying in a sense is that whatsoever is in here is what should allow you to change your input. So the parameters inside are what allow you to change what? Your input. So the next thing to talk about is what? Arguments. Arguments. So arguments are actual values passed when calling the function, right? So when we are calling a function, the arguments that are passed when calling the function are known as what? The actual values rather that are passed when calling the functions are known as arguments. So this is our parameter. What allows you to enter an input is your parameter, but the input you're entering itself is an argument, right? So this input we are entering here is known as the argument. The argument. So it's the actual value. that we impute into the function when calling the function. Remember, we only imputed this guy, Eben, Ben, and Ty only when we did what started calling the function. So here is it now. Because we are calling this function greet, we have to bring what? An argument. And that argument is what? Eben, and the next one is Ben and Ty. But the parameter here is what the parameter name here is what allowed us to enter this argument even. I don't know if that is clear enough, right? So return values, return values. They use the value the function sends back to the user, or rather, let's say the value the function sends back to the caller using return, right? So when we say return, okay, let me use this one round for an example. All right, parameters and arguments, right? So we say what? Define add. This is a function named add. So your mind will already tell you that whatever parameters should be here, that are here rather, you are expected to do what? To add, sorry, you're expected to do what? To add them together, right? So you return A and B. All right. So we will be calling this this guy very soon, but let's try to deal with something that's to clarify us first, okay? So we are saying that we define add A and B, right? And then return A plus B. So this value, A plus B, that we are returning is the return values. So most times I refer to it as what the output of what your function. Because since your function is required to perform a specific task, the result of that task you're performing or you've performed is known as what? The return value. So if I should run this guy now, remember, because I do not call the function name, it will run, but it will not display your result. But here, we are saying that your result should be equal to what? Add. Remember, because we've saved this guy, we've initiated this guy, add, to be a function name. Whenever we use it here, and then we give it some arguments, we passed in arguments 3 and 5. These are the arguments in this function add. And then we now print format sum, right? Sum of what? Results. So if I do this guy, you'll be giving me what? Sum is equal to 8. So the sum is actually equal to 8. All right. So that explains um the parameters, the return values, and what the arguments we're talking about. Also, without much waste of time, we could have that we can have default parameters, right? Whereby um we initiate a parameter and at the same time we pass an argument into the parameter. All right, this is what I'm saying now. I have um define greet, right? Sorry, my okay. Define greet, and then name ought to be the second name ought to be what? The name ought to be the parameter of this particular uh, code right now. But at the same time, I'm passing an argument known as what? Guess. So this is the argument I'm passing into it, guess. And then I have what? Print welcome, format welcome what? Name. So the name that will appear for the first one will be what? Um, will be the name that should appear for the first one will be how do you call it now? Will be guess, right? But at the same time, I can still reuse that code. Okay, so let's run this first and see if it works. Yes, welcome guess, right? Remember here, we only have to do what to call the function name because we've passed in a default um, arguments and parameters into it. It will do what? It will use that default parameter guess to run. While we can also reuse the same code, we can reuse the same code. Okay, here we are. We can reuse the same code and say greet open bracket even, it will still run, right? So here is it, welcome even. So you can have default parameters, and those default parameters can still be used to allow you enter some specific um how do you call it now, arguments, and those arguments will run perfectly well. So the same thing happens here. We have square a number, right? Sorry, this guy should have been um let's see, square. Okay, yeah, that's correct. Okay, square a number. So we have define square, right? So this square, there are two ways we could have it. We can have square to be a number multiplied by itself or a number raised to power 2, right? So this is it now. We have square and then we have a parameter norm, right? So this norm guy, that is the parameter, will now have return norm times norm, or norm multiplied by norm. So that's to tell you what it will multiply itself. So, and when a number multiplies itself, it gives you the square. So this is exactly what we're talking about. The result of when you pass a square, um, when you pass a square when you input 4 into the function square, it will give you what? 16, right? So the next thing we'll be looking, and I think this should be the last for this section, is a very short one, is known as scope. So the scope has to do with what? The global and the local variable. So for the local variable, local variables are variables that are declared inside a function and are accessible only within the function, right? So when you have a local variable does what? It allows you to declare variables inside the function, and you can only use those variables inside and within that function. While global variables are variables that are declared outside a function, right? And then you can also access them, or they are accessible all throughout the program, or your program. So let's try to explain what's the difference between local and global function or variables indicate. So here we have defined shots underscore message, open and close a bracket. We didn't pass any parameter here, but then we have a variable here known as message, and the message is what? Hello from inside the function. Print the message, and then when you say show message, open and close parentheses. So because why we didn't put anything here is because we did not demand a parameter here. So this variable message is what makes this particular function a local variable, because this message was declared inside of the function show underscore message. So assuming it was not inside here, we will say what? It is a global variable. But because it is within this function, remember, when once you have this column, this column guy, and then you have indentation, indentation. It means that you're still within the jurisdiction of this function known as show underscore message. So, but then when you call on this guy, it will display the message to us. But for cases where we have global variables, so here, remember we say global variables, so we have here to be what? A global variable. A global variable is variables that you declare outside the function. So here we declare the variable outside of the function first, and then we now started defining our function, define access global, open and close, and then we print global variable, global underscore variable, and the access underscore global will now give us what? I am global, right? So that alone will let you know that that is a global function. Then the next we can always or we can always modify our global function. So modifying our global function is that we have a global function here. Remember when we we're talking about the while loop and the for loop, right? So for the for loop, rather for the while loop, there should be an increment so as to meet up with your targets, right? So it's just like when you are increasing with respect to one or decreasing with respect to one, as the case may be with respect to what you're doing. So we have a function here that requires us to increase or to perform an increment count, right? So then we have a counter, and our initial value for our counter is what? 0. Then we remember, since we have already declared this count outside of our scope, it is known as what? A global variable. So we have our function increase, open, and close. Then we have this guy here. So the global count, right? Look very well. You're now declaring global here. And then you're saying what? Count. So this global, now you're bringing in this global into this place, and at the same time declaring that same global inside of the function. If you look at here, we did not actually declare, we only said we should print it out, right? So here we are using that function to do something. So for us to use the function to perform anything, we have to globalize the function. That's why we made use of this word global. So for us to do that, to now increase by 1, so you realize that what our counter will now become should be what? 1, right? Other than the regular 0 we had previously for count. So we have practice exercises. Yeah, I'll just talk briefly about them. When you get the notebook, you go through them very, very well. So the first one is a factorial function. So we have to write a function to compute the factorial of a given number. The steps, the first one is we define the function factorial with one parameter, right? So one parameter n, and then use a loop to or use a loop or recursion to calculate the factorial, and then you return the result, right? So by so doing, this is how it looks like. We define our function name as what's factorial open bracket n, and then our quotation, our how do you call it now? Our colon, and then look at this now. Remember, for factorials, the factorial of 0 is 1, and the factorial of 1 is 1. So we are saying here that if n is equal to 0 or n is equal to 1, return automatically 1. Reason is that mathematically, when we are looking at the factorial of 1, the answer is usually what? 1, and the factorial of 0, the answer is 1. So it will return 1. So results will be equal to what? 1 for that particular one. Then for I, in range of what? 1, n plus 1. So your results should be what? multiply your value by that I. So let's explain this. Remember, this guy is for this. Once you have 0 or 1 as your end value, you're returning 1. Then we now said, after returning 1, if I should have, there's results here being equal to 1. This is our start point. Remember, if you have factorial 2, factorial 2 is usually 2 times 1, right? Which will be what equals to 2. So what if I have 3? So factorial 3 will be what? 3 times 1, 2 times 1, right? So I now have a beginner here, which is 1. So for every value greater than 1, they must always include 1 as its multiples when you're looking for the factorial. So that's why I'm having result equal to 1 as my starter, right? And then for I in the range of 1 down to n plus 1, no matter the number of values I have, plus 1 being the maximum, right? I will now have that the factorial will be equal to that particular result I have, right? Multiply it by I. So the more you're increasing, you're also this is not increments with respect to addition. We are now increasing with respect to what? Multiplication. So if I should have my n to be 3, it will be what? 3 times 2 times 1. So if I have my n to be 4, it will be what? 4 times 1 times 3 times 2 times 1, right? And then we return the result. So let's test our output and see what we get here. So let's start with that of 0 and see if it's actually what we think it should give us. I'm coming. Let me try to. Okay. All right, let's run this. We'll have 1 here, right? The reason is that we have print factorial 0. And mind you, we said when n is equal to 0, we should return what? 1. And then when n is equal to any other number, this is 5 now. So let's run this. It will give you what? 5 times 4 times 3 times 2 times 1, resulting to 120. So the next thing is the next exercise will be on prime check, prime numbers check, right? So you write a function to check for prime numbers. So I'll leave you with this to actually confirm if you understand this. So if you have any question, you can always reach out to me to see that we solve those questions and those problems together. So this will be the end of today's class while getting ready for the last topic for this week.